welcome back. So in this video we are going to understand the LeetCode problem number 1680. It's a concatenation of consecutive binary numbers. So the question that we have given is very easy. So imagine I have given you a number n equal to 12, and I will tell you that you have to convert this number from 1 to 12 in binary and join all of them together, convert the massive binary back into the decimal, right? And if it sounds easy, now imagine n we have given is 1 lakh and the binary becomes thousands of bit long. So how do we solve this efficiently without building a giant string? So today we will break down this problem in very simple steps and we'll try to understand the bit shifting magic behind it. So let's try to understand, because the questions the says that every number that you have given, let's suppose from, if n equal to 12 we have given, means every number you have to convert from 1 to 12 into binary. We have to join them together and then you have to convert them back to the binary. But whenever a number comes a big number as n equal to something big like lakh of lakhs, so it's very hard to do the same thing, right? So that's we will understand in this video. That is why the question saying that it's a concatenation of consecutive binary numbers, and what we need to do. So let's understand in the step by so you can solve this problem. So let's understand that we are given a number that is n we have given, right? N we have given. Okay, we have given this number integer and we must take number from 1 to n, right? So if we are taking, means we have to take this number from n. If the n is given, we have to take 1 to n. Once we will take 1 to n, then we will convert each to binary. This is what the question is saying, right? Then once we will convert them, we have to concatenate them, means concatenate them back to the n, right? Then we have to return the decimal value, and in the module 10 to the power 9 plus 7, something like that we have to take. So let's start with the very small example so you can understand. The question saying, it is very easy to understand because the question saying that we have given n, and if the number we have given, the very simple steps means you have to take the number from 1 to n. Then you have to convert each number, right, into binary. Then you will concatenate it back, and once it is concatenation done, then you will return the decimal value into 10 to the power 9 plus 7. Okay, this is what the question is saying. Let's try to understand further. Now think that if I'll take, for example, if I'll take n is equal to 3, it means we have to take the number from 1 to 3, means 1, 2 and 3. Now we have to convert into the binary. So for the 1 it will be 1, for 2 it will be 1 0, and for 3 we know that 3. Now once this is done, we have to concatenate, right? Once we have converted, we have to concatenate, means we have to do 1 plus 0 plus 1 1 1. So if we'll do this, let's do how we can do that, right? So once we concatenate this number, right, it should convert some value, right? So if you convert this value, it should get converted into some binary itself, right? So it will become what? So the very first is comes is 101, so it will become 1. Then we have 1 1, so 1 1 is 1. We will take one leading value, right? Now it's coming, there is 1 and 1, right? So it will become what? 0. Then we have is 1 1, right? So it will become 1 1. Yeah. Now we will convert this value into decimal number. So let's convert. So now we have to convert 11011 into decimal. So once you will convert this into decimal, so this value will get converted into what is, if you have to convert this number, it will get converted into decimal value. It's 27, right? 27. And that is why the output become what? If you see the answer should come 27. And this is our answer. So this is the small value we have, right? We take for simple numbers. Then you will say, okay, but we were talking about if n is coming 1 lakh like this, right? If it is coming like this, we can't build the full binary string because it's very hard to do that. So what we will do, it's very difficult, right? Because we cannot build the so big binary number string, right? So here is the important idea that when you concatenate the binary numbers, you are actually shifting existing bit to the left side, right? Let me tell you how. So when we are concatenating the binary numbers, what we are doing here, see here, basically if the thing we are doing, we are just shifting the value to this side, right? Means the left side, correct? So when we are concatenating the binary numbers, we are actually shifting the binary shifting the bits to the left side, right? Left. Then we are inserting a new number, right? So can we say that the binary concatenation is binary concatenation binary concatenation is nothing but it is a shift, right? Or which shift? We can say left shift, right? We can say left shift plus add. Okay. If we'll talk about binary shift is nothing but binary concatenation is nothing but the left shift plus add. If current result is, let's suppose if current result is 110, right? And the next number is 3, right? Let's suppose, and next number is 3 we are taking, okay? And if you'll take the binary, it is 1 1, means there is 2 bits is there, right guys? So we have to shift left by 2 bits, correct? The current result is 110. Now what we need to do here, we have to shift left by 2 bits, correct? It means we can say 110 left shift 2, so it will become what? 110 and then 00, like this. And then we have to add 3. It means that 11000 plus 1 1 we have to do, and that is why we will get 0 1 1. Right? Are you following me? Right? So that's exactly called the concatenation, right? Okay, guys, it is called concatenation. So the formula becomes what? It's very easy to understand if you understand. It means if you have a result, then what you need to do, you will say, okay, result, we'll take the left shift number of bits plus I. This will become your formula, you can say, like this. Okay, so make sure that you understand this concept. If you will understand this concept, it will become easy for you to understand. Okay, guys, let me explain it again. So basically, from where we have started, that we thought that if n we have taking 1, then we have to take from 1 to n as a numbers. Then you have to take convert into binaries. Once you will do the conversion, you have to add it back, and once you have added back into binary, means connect you have to do. Once it is done, you have to convert this into a decimal, and that is what it is coming. So this is our answer. But we thought that if n equal to lack of the value is there, it means the binary concatenation we have to do means left shift we are doing actually and add. If you see here, we are doing the left shift and then we are adding. So very first that we will take the value, right, and we will do the shifting, right? So here what we need to do is we will first do the shifting, left shift, and then we'll do the add. Okay, if the current result is this, right, let's suppose, okay, so here we did the mistake. Okay, you remove it. So if the current result is this one, so the value next we have to add is 3, which is 11. There we have written triple one, that is not correct. It should be for 1 it is 1, for 2 it is 1 0, for 3 is 1 1. So you can update it here. Okay, so here we will get 2 bit, a 3 bit we have to add, right? So it's of 2 bits, right? Then we will take the shift, and this is our answer, because we have seen that left shift we have to do, right? Means shift to shift we have to do. So this value is coming to shift after. Okay, then we are adding 3, means this 3 will get added there after the concatenation. So the formula becomes that result we are taking the number of bits plus I. The I will be the value that we are going to take here as a binary. So we will convert it into binary. Okay, I hope you are understanding what we are doing here, right? So how many bits we have here? This is the important question here. Okay, so let's understand. So now the question says that, now the question is, how do we know how many bits a number has, right? So let's suppose if you know that the binary lengths, right, for 1 there will be 1 bits, right? For 2 it will be 2 bits. Okay, for 3 it's also 2 bits. For 4 it's 3 bits. For 8 it's 5 it's a 3 bits, and 8 it's a 4 bits. Easily you can take 2 and 4 formula, where you can just put, okay, if you need 5, just say this and this 1 and this 0 0. It means you have to take from here to here, and it's a 3 bit. No need to take the leading this one. Okay, so this is what we have. If we want 2, you need to only this and this, right? So 2 bits is there, like that you have to take. So if you notice something here, the bit increases only at the power of 2. It means 1, 2, 4, 8, 16. Like that it is going. So just instead of calculating long every time, right? We just need to check, is I a power of 2? If it is, it means how we will find that? We have to find how. Means every bit we have seen, right? And the bit length increases only at the power of 2, like 1, 2, 4, 6, 8, 16, like that, right? So instead of calculating long every time, right, we just need to check what is it a power of 2. If it is a power of 2, means how we will check that? I and I minus 1. If it gives you equal to 0, then it is, if it is saying if true it is giving you, it means increase bit length. Simple, right? And that is why this type of solution will take in one pass, and so the time complexity will become O of 1 in very simple solution. Okay, so let's try to understand how we'll solve this type of problem. Okay, let's continue. So very first, that we need a long and it will be a result. So result we will start from 0, correct? Then we'll say, okay, if we'll take int mod, and we'll say, okay, the value we can take is 1 10 to the power, what was that, 10 to the power 9 plus 7, right? Yeah, so we'll say in this case it will come 3 times 0, 3 times 0, like this, 10 to the power 9 plus 7. Yes, it will look like this. Okay, so we'll take the mod, right? Then we'll define int and we'll say what is the bit length is there. So as we discussed, we will write the bit length, which should be starting from the 0, and will keep increasing if we need it, right? So for the single pass we will go and we'll start from int I should start from the value 1, and we have go to till less than equal to n. From we have to convert I, if n is given 1 to n, we have go, and I plus plus, we will say that this is what the requirement is. Now once this is done, we will check the condition. What is the condition is there? We have seen that if I let's check how we'll take. The condition should be there. Okay, let's take like this. If we'll take I and I minus 1, right? If it is equal to 0, and if we'll give this true, it means we have to increase the bit length that we have talked about, right? Then once this is done, then I have to come from the if condition, right? Then we will update our result. So we'll say result is equal to, we have already talked about this, that we will take a result, then we'll do the bit length, what is the bit length is there, and once these are done, we'll do plus I that we are passing, and finally you will take the mod, right? The mod we are talking about. So it cannot break. Okay, it should pass all the test cases. Then we have to return is the result, but before returning we have to convert into the array, and that is called result. Okay, so let me submit this one. Okay, so the condition saying that, okay, we can remove this one. this part and this part is not required maybe. If, first of all we'll say if I and I minus 1, okay, not like that. Let's suppose that what we should do, I and this one, if it is equal to 0, yes, I guess this is the mistake, I and I minus 1, yeah, then submit this. Why we have taken this long, if you'll ask? Because we are shifting grows very fast. Why we have taken the modulo in every step? To avoid the overflow. What will be the time complexity? It will take O of n as a time complexity and a space complexity as a O of 1. So that is very easy, right? Let's try to understand that what we have done here in this problem. So this problem is not about the string, it's about understanding how bits move. Every time we add number, we are creating space on the right shift. That's it. Only you understand shifting, this problem becomes easy and elegant solution. So if this explanation help you in truly understanding the intuition, not just memorizing the code, then hit like this button. And if you want more deep bit manipulation problem to be broken down, please subscribe, and next time we will cover another problem where the shifting changes everything. So that's all I have in this video. So till now, bye bye.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.